Hey, good morning, folks, or good afternoon, whenever you're watching this. Thanks for tuning in. Here is a problem we had on last night's homework. We're going to have it again on today's assignment. We're doing a day 2 for circles. And I just want to remind you that we do have a textbook, right? Um, you know, I know sometimes because it's digital, it doesn't feel like we do. Like, where are my resources? Where can I find help with this stuff? So if you open up the textbook, and we're in section 3 of chapter 6, we got to get to chapter 6. Module 6 is what they call it. And we're in lesson 3. So there's module 5. Here's module 6, lesson 3, area of circles and sectors. And then I like going one page view and arrowing forward. Okay, yep, I'm in section 6.3. You want to double check. And what we're looking for is some picture that looks like our problem that we're stuck on, right? We're not sure how to do that problem right there. It wasn't in the videos. So I'm scrolling forward until I find it. Oh, here it is right here, right? So it says, and this is, sometimes when you're reading textbook, kind of hard to read. It's confusing a little bit. It says the ratio of the area of the sector to the circle is the same as the ratio of the central angle to 360 degrees, right? Let me zoom in on that guy. It might be hard to see. Let me say it again. The ratio of the sector to the whole area is equal to the central angle to 360 degrees. And then what they do is they multiply both sides by pi r squared to get the pi r squared over here and the area of the sector that we care about by itself. So really what we have, I just look at this. The fraction, the x degrees over 360 is the fraction of the circle that we're talking about, the fraction that we care about, times the whole circle. So that's what I'm going to write, hopefully right over here. My pen wasn't working the first time I opened up this program this morning. So the fraction of the circle I care about times the area of the whole. Okay, let's write that. Area of whole circle. Okay. All right, so here we go. So what's the area of the whole circle? Well, it's pi r squared, right? And then the fraction is something out of 360. So what angle do we have out of 360? Well, it's 51 degrees, okay? Definitely some Desmos needed here, right? So the area, let's put A for area. Our area is equal to this equation here, this formula. Oh, we're going to plug in 2, right? Shoot, I should have done that right away. I'm going to plug 2 right there. So let's get over to Desmos and stick some things into the calculator. Sorry, I probably should have had this open. Okay, so what did we have? We had 51 degrees, 51 out of 360. 360, come on, man. And then we had times pi. I think the radius was 2, wasn't it? 2, and it would have been quicker for me to just type in 4 right there because I know 2 squared is 4. So my answer should come out to be 1.7 or 1.8 actually if you round to the nearest tenth, or 1.78 if you round to the nearest hundredth. Let's crank back over to the problem. So yeah, the radius was definitely 2. And it says round to the nearest tenth. So let me look again, 1.8, and the units are meters. So I'm going to put down 1.8 square meters. Okay. I hope I made that clear. The second type of problem I wanted to go over in today's homework happens in problem 4. It says find the area of the circle that contains a sector described below. So now they're telling us, let me just put a little sector down. When they say the word sector, they're talking about, and this could be completely inaccurate, okay? I haven't even fully read the problem yet. I don't know how big the sector is, but I'm going to say it like, looks like, oh, shoot, it says a 30-degree angle. So I probably should make something that looks like a 30-degree angle. My bad. Okay, so let's erase this other thing down here, this other radius. And now we've got maybe something that's a little more realistic. So we're looking for the area of this sector right here. And it says that the sector's area is 210. So they're giving us part of what we care about. They're telling us something about the fraction, and we're supposed to find the area of the whole. Area of whole circle, right? Isn't that the formula that we just saw? The area of the sector is equal to the fraction of the circle we care about times the area of the whole. So what does it tell us? Telling us again, the sector is 210. So I'm going to put 210 on the left side. The fraction is 30 out of 360, right? And the area is what we're looking for. So I'm going to call that x, okay? We often like a nice simple variable like this. Let's see. I could simplify 30 over 360. That would go into 360, I think. Let's see. The zeros are going to cancel out, and then there's a 3 in both these guys, and I think that's 1/12th, isn't it? So I've got 1/12 x equals 210. I really probably didn't need to do that. That simplifying. What I really want to do is take my fraction and I want to divide it into 210. So I'm going to take 210 and I'm going to divide it by 210 divided by 1/12, because if I divide this side by 1/12, I would divide this side by 1/12. And I know what some people might be doing right now. They're screaming at their screen saying, look, Nelson, you can just multiply by 12. I know I can multiply by 12 on both sides. And I'm going to show you why that works right now. Like when you divide by a fraction, it's the same thing as multiplying by its reciprocal. So I'm going to multiply by 12 over 1, right, which is just 12. So right here at this step, see, I could have taken 12 times 210. And then if I took 12 times 1/12, these would multiply out to 1, right? So that's really what I want. And 12 times 210 is, let's see what it is. 12 times 210 gives me 2520. So the area of the whole circle is 2520 square centimeters. Okay, so 2520. Boy, I hope I made that clear. You got a couple more problems like that on our homework. The last one I wanted to kind of give you some hints about are ones that we struggled a lot with yesterday. We not with the first part, but the second part's a little tricky, right? So if it says the diameter is 11.5 inches, and we're supposed to find the area of this, when they say disc, it's just a circle, okay? Like a frisbee, like disc golf, that kind of thing, right? So if the diameter is 11.5, then the radius is equal to, let's see, that would be what, 5.75, I think. 5.75. I just took half of 11.5. Let's just double check it on Desmos, okay? 11.5 divided by 2 is definitely 5.75. Okay. Radius is 5.75. Then the area is 5.75 squared times pi. So let's jam back over here, put a parenthesis there. Let's square that and then multiply by pi. And we've got 103.9. Okay, so this is 103. Do I round to the nearest tenth? Yeah, 103.9. Now, this is the part that really messed with us yesterday. It says that the sheeting needed to produce a flying disc costs 1 cent per square inch. Well, this is beautiful because we have square inches up here. If I didn't have square inches, I'd have to convert to whatever this was, in like square feet or square yards, and that's where things got a little messy. So on this situation, check this out, 103.9 square inches times 0.01 dollars. I'm going to put the units after instead of having the dollar sign in front. Dollars per square inch. Okay, so what happens here when we multiply is that, this is like over 1 square inch. So I could divide before I do my multiplication. When I divide the square inches into square inches, those units cancel out. They divide out, in other words. And so now we're down to just straight up money. And when you multiply by 0.01, it's going to move the decimal over 2 spots. So I think we've got $1.04 maybe. So 1.039, if we round to the nearest cent, I think it's going to be $1.04. The part that was tricky yesterday is this unit down here wasn't in square inches. It was like square feet. So if we need to convert like square inches to square feet, here's what I was trying to say yesterday, that if you had a square, okay, by the way, the answer is, I think, $1.04. If you had a square foot, let's say, okay, 1 foot by 1 foot, that's equal to 12 inches by 12 inches, right? So when I multiply 12 times 12, there's 144 square inches in 1 square foot. Let me write it out here. 144 square inches in 1 square foot. So like if this was in square feet, we would have had to take how many square inches we had and divide by 144 to convert it to square feet. All right, so let's say we wanted to do that. It was 103.9 square inches. See, if I multiply by something with square inches in the denominator, this is what we sometimes do in science. So like we don't want square inches, but we want square feet. We need to know what is an equivalent relationship between square feet and square inches. Well, 144 square inches equals 1 square foot. So I'm going to put 144 right down here by the square inches and 1 square foot right there. When I do the multiplication, it's really, I'm dividing by 144 and multiplying by 1 over here to get the square inches to cancel out to get my final answer as square feet. We don't need to do that on this particular problem because the units are all matched up. All right. Hey, thanks for watching my video. I hope that helps.